Woohoo! We are live, and this is Math 60 Intermediate Algebra, and we're going to be talking about exponential functions and logarithmic functions. Woohoo! And the sound of the bell means we are so excited. So, pardon me. We're going to start off with exponential functions, and the problem with not being in person is that it's a little bit harder to do this, to all come up with the numbers. So what I decided to do was I just printed out the table of values here for you. Now, this is not an exponential function. This is our old friend, the parabola. And this parabola was graphed. We've got y equals x squared, and we're going to study this in more detail in chapter 10. But basically, this is a parabola. If I have any value of x, 0, 1, 2, 3, -1, -2, doesn't matter because I'm squaring x. All the y values are positive or 0. So you'll notice that the graph, and unfortunately, I can't get it to print out with all the things that I like, so the X and the Y and the arrows, but the graph is going to appear entirely up here in the first and second quadrants, and also right there at the origin on the X-axis. So this is pretty cool. This is a parabola. Parabolas are really wonderful, and they help us study a lot of things, but it is not an exponential function. However, I thought we'd start off here because it's fairly straightforward. So let's take a look at the details. The domain x are all real. So we could say x is in the set of real numbers, or we could say x can range from -infinity up to infinity. And of course, those are just concepts. So very, very small, very, very large, as far as you want to go. The range is y is greater than or equal to 0. So in interval form, this would be 0 to infinity. This is the range. The x-intercept and the y-intercept are both 0, 0, because that's the only time it hits either of the axes. So that's our parabola. And again, we study this more in depth in 10.1, but it's kind of cool. And we say, oh, look at that. It's a little smile. Isn't that lovely? And then we move on to something a little more exciting, maybe. Now notice this is very similar, but this one is y equals 2 to the x. So instead of x squared, it's 2 to the x. We reversed their positioning. And notice what happens. Same situation. No matter what x is, y is always positive. But here's the interesting thing. Because when you take exponents, so like 2 to the 0th is 1, 2 to the 1st is 2. Remember, the vampires, 2 to the -1 is 1/2. The problem is there's never a value of x that allows 2 to the x equals 0. So nope. There is no x-intercept, which is interesting. So as we look at our graph, there's x. I got to put my arrows. There's y. Notice that y gets very large. It's heading up quite fast. But then over here on the left, these are negative values of x. So this is like 2 to the -1st is 1/2. 2 to the -2nd is 1/4. 2 to the -3rd is 1/8. So what happens here is that the y values get closer and closer and closer to y equals 0, but they never touch. And so there's something, and you can see it written down here, something called an asymptote. The asymptote is the axis, so the x-axis, or if you want to call it y equals 0, same thing. This line, this horizontal line, is a fence. If this were an animal, it would be coming down, it would walk along the fence and get closer and closer and closer and closer to the fence, but it would never touch. So the domain is all real numbers, so we can put any number we want into it. But again, the range is, and notice this doesn't have the equals attached. This is y is strictly greater than 0. So the domain would be negative infinity to infinity. The range would be 0 to infinity with a parenthesis, not a bracket. So what I would like to do is to compare these two functions on Desmos, because we can do that. I can do that right here. So let me bring in my computer, my tablet. I'm going to turn off the light so that we can not see, be all blinded. So I'm going to get y equals x squared for the first one, and then y equals, and then 2 to the x. So you see the way Desmos works, you see that there's a blue line, that's the 2 to the x is the blue line, and the red line, the red curve, is x squared. So you can see on the left side of the graph, when x is negative, x squared goes back up because you're just squaring the numbers, so they get big and very positive. But notice that on the left, 2 to the x, because it's like 2 to the negative 1, 2 to the negative 2, we're actually making fractions. So this is that asymptotic behavior. The x squared does not have an asymptote. It just keeps getting bigger and bigger. Nobody tells it where to go. But with the blue graph, we do have this asymptote, and you'll notice that it looks like the curve is sitting right there on the x-axis. But if I pull it apart, you can, and I don't know how well it shows on the video, but it's ever so slightly not touching it. And no matter how far out we go, I can, as long as you're willing to look in detail and really pull it out, you can see the x-axis and this blue line do not intersect. They never do. But that is fun, but not what I'm interested in. What I'm really interested in, I went too far. Oh man. You know, when you're having fun, you're having a fun math graphing party and somebody has to go too far. This is an interesting point right here. What's going on right here? Right here, when x equals 2 and y equals 4, the two graphs intersect. Notice that the exponential, the one where x is actually in the exponent, is up here, and then they cross right there, and the x squared, which is in the red, pops up above. Let me see if I can. Unfortunately, my iPad is too small to show this to you. Can you see that? I'm not sure you can in the video, but look at what happens. The red curve, so the x squared, the parabola, they intersect right there. So at the point 2, 4, they intersect, and the red, the parabola, pops up on top. And then right here, which is at the value x equals 4, they intersect again. And then look what happens. If we go really far out, the blue curve almost looks vertical. It gets so big so fast, it goes straight up. So which gets faster, which gets bigger faster? The x squared or the 2 to the x? And the answer is, well, they kind of wiggle. It's kind of neck and neck in the beginning, but eventually the blue curve, the exponential, will get much bigger much faster. And the parabola, which is still getting pretty big pretty fast, is not quite as steep, if that makes sense. So exponentials get big really fast after a certain point. Now, again, back to where they intersect. This point, x equals 2, y equals 4. This point, x equals 4, y equals 16. So let's take a look. When x is 2, in the red, 2, sorry, I don't know if I can make that. I don't think I can make it bigger for you, unfortunately. When x is 2, 2 squared is 4. In the blue, when x is 2, 2 squared is 4. So they have matching values. What happens when x is 4? Well, in the red one, you get 4 squared, so that's 16. And in the blue one, you've got 2 to the 4, which is 2 times 2 times 2 times 2, also 16. So we can see these two intersection points. The one right there, it's not giving me the values. There we go. We've got the point 416 and we've got the point 24. Those are the two intersection. Oop, I lost them. See if I can get those back. Okay. So I will be sure to take a screenshot of this and include it in the notes, but I encourage you to get your own copy of Desmos. You can either get the app as I have, which because I find it very useful. If you're going on a math, I encourage you to have access to this, but you can also get to it in a browser. So you can use your browser to go over and you can use it as a web application. Okay, so I will screenshot this. There we go. The click means it's working. Oh my goodness. That was really funny. I should know not to put my tablet on top of my paper. It totally wrinkled it. Okay. What do you notice? So they intersect. Ooh, I did leave myself enough room. I'm going to write it up here. Y equals x squared and y equals 2 to the x intersect at 2 points in the first quadrant. The points are 2, 4 and 4, 16. After x equals 4, 2 to the x is much larger than x squared. And that's really important. This is the exponential. And exponential functions are known for getting really big really fast. They're also known as, they tend to, the model, the exponential model tends to describe anything that grows like that. So that's bacteria, rabbits, humans, anything in the wild that has babies, as long as you're not limiting them. So as long as there's plenty of food and space, a lot of creatures will grow exponentially. Money, in terms of when you put it in the bank or when you owe money to the credit card, that grows exponentially. So it's things that grow very fast. And then we come down here and I said, an exponential function is a function of the form f of x equals some base to the x. And now what's important is the base. It needs to be positive because otherwise, if it's just 0, it won't do anything. It'll just be 0 all the time. And if it's negative, it's very confusing because negative, like -1 squared is 1, but -1 to the third is -1. So it bops around. So it's just too confusing. So we're going to keep b positive. And then why do you think b can't be 1? B can't be 1. So think about, what if the base is 1? 1 to the x is just boring. It's just 1. So we don't include 1. We only include positive numbers, and those are exponentials. And if you have an exponential, the graph will look like this. And all exponentials will share 1 point. So if you look at this graph, this again, the graph of y equals 2 to the x, what point do you think they all have in common? I don't know if it's obvious, but this one, the point 0, 1, is common to all exponential functions. Why? Well, because, well, all simple exponential functions. If you make them fancy, you can move them around a little bit, but the basic exponentials, I should say. What happens at 0? If 0 is your exponent, any number to the 0th power other than 0 equals 1. So they're all going to go through that point. Woohoo! How are we doing? Ooh, we're at 15 minutes already. I am going to have to go to I will hold off and I will do another video. So we'll go to the next video. We'll hold off. There'll be another video where we're going to be looking at more exponential functions, which is very exciting. And then we're going to talk about a very special number. Woohoo. It's very exciting. I'm going to do a whole oral report on the number E, Euler's constant. Woohoo. Math on, guys. Math on.